So I'm going to go ahead and announce our speaker for today. So we have Dr. Daniel Mason DeCroze. He's a senior research associate with the Department of Global Development at Cornell University. He was just telling us, asking us about our weather compared to their weather, which is much colder than it is here in Tennessee. But we're excited he's here to join us. His research focuses on food system transformation kind of broadly, and then having done work on a range of topics in this space, like assessing climate adaptation and mitigation challenges, estimating potential impacts of current and future diets on public and planetary health, exploring the role of technology and innovation to contribute to alternative food systems, and identifying potential vulnerabilities in current and future food systems. So certainly a relevant topic for right now. And we're excited to hear from him. So if you have questions, feel free to post them in the chat throughout the presentation, and then hopefully we'll have some time for discussion at the end. And again, I'll post up that link for the student summit in the chat right now. Hopefully you can all see the slides, but let us know if you're having any technical issues. And with that, it's over to you, Dr. DeCroze.
Well, hello, everyone. Thanks for inviting me. And I think it's definitely an interesting topic to try to think about the consequences of climate change and human health and the many ways that its impacts may be sort of intermediated through human systems and the effects it has on human well-being into the future. Let's see here if slides work. And so maybe start off with a little bit of some definitions of things. With the title had Polycrisis in the Anthropocene, and it's useful to start thinking about what the Anthropocene means. And essentially, it's this idea of where we start to really notice humans' impact on the environment at a sort of geological scale. And so we can really start seeing that somewhere in the time period of the 19th century, with the consequences of the Industrial Revolution, rapid population increases, and our increasing sort of use of natural resources across the whole spectrum of different dimensions, from water use, land use, fossil fuels, plastics. And so it starts to show that our activities now start having impacts on the environment in a way that is more systemic than what would have happened in earlier parts of human history. These activities have come with a lot of positives. I mean, as the world has more than doubled the population since 1960, we've been able to produce more food than ever before, and in fact, produce more food than what is currently needed, even as the distribution and the equality of access to those things is still a serious issue and problem, and we still have large numbers of people who are suffering from hunger or unhealthy diets. And as we keep moving forward into this century, we're going to start seeing the consequences of our impact on the environment having reverberations back onto our own activities, and whether this is through climate change, through the biodiversity crises, as some of you may have heard, in terms of sort of worries of we're in an extinction crisis, water quality and others, things like these start to have their own feedback and negative consequences on human well-being. Continuing a little bit with definitions, it's always helpful to sort of think of what's the difference between climate and weather. We often sort of use these somewhat interchangeably. Weather is more of a short-term description of what's happening in the atmosphere, things like temperature, humidity, wind, cloud cover, how sunny it is. And it's usually we're talking about weather in a much more local context. And so this is really important to think about, because climate change is a global phenomenon, but its impacts on human well-being are local. And so we have to think about climate change both as sort of the average changes that are happening over long periods of time, over sort of broader regions, and how those sort of percolate into impacts through weather and other events that happen more on the local scale. So what do we know in terms of what's happening? Well, with climate, we see increasing temperatures both on land and on oceans, greater concentration of CO2 in the atmosphere. This also has consequences on greater acidification of those oceans. What do those consequences have on weather? Well, essentially what we start seeing is a lot more variability and unpredictability. If we think of climate as sort of the bounds around which local weather operates within, as temperatures start to increase, then what we can start seeing is that average temperatures and weather, we start seeing warmer temperatures broadly, but we also start to see a lot more variability. And so that means both in extreme heat, but sometimes also with surprising spurts of cold weather. And a lot of this happens because of perturbations through different Earth systems and circulation systems that move hot and cold air and water across the surface of our planet. Other aspects that we can think about in terms of climate moving forward is that we should be expecting, with warmer temperatures on average, that means that there's more holding capacity in the air for water, so more humidity and more rainfall, but with a lot of regional variation. And so what we start to expect to see is that temperatures will not increase uniformly across the planet, and we'll have higher temperature increases in northern latitudes, higher elevations, mountains. And with rainfall, it's hard to predict what's going to happen because of the complexity of our systems, but a lot of the modeling seem to suggest that areas that are currently arid are likely to become even drier, and areas that are wetter are likely to become even wetter into the future, but again, with a lot of variation and variability and unpredictability across weather patterns into the future. Some other things to think about as we are talking about it with climate change and sort of extreme weather events. It's always useful, I think, to think about how these types of events ultimately have impacts on human well-being. And it's useful to sort of think about how we as human societies have evolved to think about extreme weather events. And so if we were to look at how human societies described extreme weather events, sort of disasters, for most of human history, we would have thought of them as sort of acts of God. In fact, we still have this term acts of God when we start thinking of insurance policies. But one of the things that you can kind of get out of this is that there is a sense of responsibility, and these events then are punishments from the divine retribution for human failing. Which is an interesting concept because it sort of has this idea that somebody's to blame for these events that are occurring. One of the challenges with this, though, is often then it means that people who are suffering from these events are themselves the ones who caused it, which, as we start thinking about that, is not really how these things ultimately work out. Then as we start moving kind of into the Age of Enlightenment, there's more of this language of acts of nature or natural disasters, which kind of remove a little bit of the responsibility language that we had in that idea of sort of a divine retribution. But it kind of gives them a sense of sort of that they're inevitable. These are like random or statistically outcomes of systems, and that then there's no human blame around these as well, which is not exactly correct either. And as we start thinking more in terms of like a risk or resilience framework, then we start thinking about how these types of natural phenomena, their impacts on human societies and human well-being are really determined by where these things happen and what are the sort of human systems that are in those places when these events occur. And so we think about things of like vulnerabilities, exposure, how do the systems that we've set up, how do the economies that we've created put different people into greater or higher vulnerability to these changes, to the hazards. And then also, what do our responses to these events, how do those themselves potentially influence our vulnerability, the risk of these events? And so if we think about the concepts of like building back after an extreme event, they're talking about this now in California with the forest fire, with the wildfires that they've had. If you build back exactly the same way that you just did, that response to that event means that all the vulnerabilities that used to be there will be there again. And so, if we choose to respond in a different way, we maybe can respond such that in the future we've reduced some of those vulnerabilities, even as those responses themselves may make us more vulnerable to other outcomes into the future. So climate change impact on human well-being is very multi-dimensional because of the way that these things are connected across a great number of very complex biophysical and social systems. It's hard to sort of say that there's just one impact or one pathway through where climate change will likely have consequences on human well-being. I particularly like this figure that came from Sam Meyer's article from a few years ago, which is more focused on the consequences through the food system, but still starts to highlight that there are just many, many different ways where these types of effects may eventually percolate through the system, whether it's through higher temperature, through greater concentration of CO2 in the atmosphere, if it's through acidification. All of these things have various different impacts across different sort of layers of these different biophysical and social and human systems that interact in often unpredictable and complex ways. And what do we know right now? Well, generally speaking, there's a lot of language around climate change as being sort of force multiplier in terms of risks and vulnerabilities. And it's important to think about that we are not starting from a tabula rasa. We actually have societies with a great deal of vulnerabilities and challenges that they're facing today. And then climate change is just going to layer on top of that. And so this map here comes from the WRI Aqueduct, and it highlights a whole range of different regions that are already experiencing today high levels of water scarcity. And what we can expect then is that climate change will likely make many of these places even more at risk of water scarcity. Places which are already experiencing risks of extreme high heat during the summers, well, those risks are only going to become greater. But it's not necessarily inventing sort of the challenges. It's magnifying or making them even worse. And like I said, it's really difficult to sort of describe everything and all the potential impacts it might have on human health. So I've tried to pull out some of like the key pathways and some interesting different pieces, and then also potentially highlight some aspects that are a little less maybe top of mind, just to highlight how complex some of these different things can be and the potential perturbations that it might have through human societies and ultimately to effects on human well-being. Currently, most projections suggest that we're looking at temperature increases about 2 degrees Celsius by mid-century to 2.5 by the end of the century. And so this little nugget, we could sort of think in both positive and negative framings. One is that suggests that we're failing to meet the Paris Agreement with the goal of trying to reduce climate change to 1.5 degrees by end of century. And there's a lot of evidence to suggest that temperature rises anywhere above 1 degree centigrade from pre-industrial times will start to increasingly have negative impacts and increased risk. And so there's certainly a negative side to see to this. On the other hand, if we were to think just about 10 years ago or 15 years ago, the baseline projection for where we were going for temperature increases by end of century were in excess of 4 degrees centigrade. So we can also paint a story of how this number itself is also maybe gives us reason for optimism that shows that efforts to reduce greenhouse gas emissions, improvements in technology, the expansion of renewable energies have started to have an effect and have started to bend down the curve of emissions. And so I guess as in many of these things, there's both reasons for pessimism and concern, and at the same time that there's reasons for optimism that actions today can have positive effects towards the future. High temperatures in general, we've are associated with increased risk of a lot of different negative health outcomes. There's a range of studies that show in terms of sleep quality, mental health. There's also a line of research that highlights that higher temperatures and high temperatures are also associated with higher rates of domestic violence and conflict. There's also greater risk of cardiovascular disease. And then there's also evidence that higher temperatures can also lead to decreases in just productivity, which may mean that futures where economic growth is slower and that we might have less economic development. But as I was saying before, climate change is global, but the impacts will be felt locally. And then the challenges of predicting or projecting what that might mean becomes a lot harder. So currently, the risk of cold weather is actually higher globally than the risk of hot weather. So if temperatures are increasing on net, we might see sort of a benefit from reducing risk of cold weather, even as we increase the risk of hot weather. Different locations will have very different levels of sensitivity to changes in temperature. There's been studies that have highlighted that 1 degree increase perhaps in India or South Africa may not have the same negative consequences of 1 degree in a more temperate region that's less used to warmer temperatures. On the other hand, what we also know is that the risk of extreme heat today is disproportionately felt in low and middle income countries. And so as higher temperatures go, that risk may increase. All of this is working around demographic trends that are also important to note. Populations are getting older in most regions outside of sub-Saharan Africa and South Asia. We're also seeing a world that's going to be increasingly urban. I can't remember the exact date when we switched from being majority urban versus rural globally, but we've already passed that. And most experts are assuming that urbanization will continue to increase, which is a concern given the urban heat island effect, which in many cases can increase the temperature by 4 or 5 degrees compared to rural areas just outside of the city. So if you think of rising temperatures with an urban heat effect, the possibilities for sort of magnifying risks in urban areas, which are also growing, we can start to see how these different things, how climate change itself is kind of a risk multiplier. So climate change historically has been a major driver of human conflict and population displacement. If we think, going all the way back to the sort of the steppe nomads that have crossed the Eurasian plate, many of these things were spurred on by changes in climate, droughts, and things like that. So we already know that these types of things can have serious ramifications in terms of stability of human societies. This isn't just a human phenomenon. We'll also be seeing how crops, plants, animals can also then start to move in response to this. And this will then create new potential areas of concern and risk in terms of human well-being. We're already starting to see that the areas where mosquitoes can inhabit are starting to change. This presents the risk of new areas becoming prone to mosquito-borne diseases like malaria, Zika, dengue, etc. It also has, we have already seen evidence that animal pests and diseases and crop pests and diseases are starting to move northwards and southwards towards the poles, presenting a whole range of new risks to different societies and systems. The fact that we don't have as many cold nights and winters in North America, we are already starting to see that as a risk, for example, with greater exposure to ticks and tick-borne diseases that before would have been more managed through the tick population shrinking substantially under cold winter. And so these types of things we expect will become more problematic. They could add new stresses to pollinator populations that are already under pressure. So this can have consequences in terms of how productive agriculture is, with particular concerns with fruit and vegetable production. But if we think about then the responses, if we think of that 4 sort of components of the risk framework from the IPCC. One of the responses might be to increase the use of pesticides to sort of manage this. That itself then might have problems with human well-being in terms of increasing exposure then to toxic chemicals. One of the major challenges I think that climate change is going to do is it's really going to be pushing up in terms of unpredictability. And so we're going to have more prevalence of drought and extreme rainfall events. Often this will be true in the same location. Already rainfall events are among the biggest causes of mortality from natural disasters. But if we're thinking about also sort of exposure to toxic elements, these types of events, especially if they alternate back and forth, we can start seeing that sort of drought followed by extreme rainfall events can then lead to toxic leaching into soils and into water of all sorts of different chemicals that may have been left there from agriculture, but also could have then been introduced from previous flooding events, as we know that these types of events can lead to quite a bit of pollution into the environment. This also will have all sorts of different issues in terms of our own transportation and electricity and energy networks. And so we've already started to see that the Panama Canal, for example, is operating well under full capacity because of droughts there. This has increased the cost of transporting goods globally, but also has slowed things down. A whole range of river systems have in the past had moments when they've struggled to be navigable because of drought conditions. And if we think about the example here in the US, there have been instances where the Mississippi River itself has become challenging for navigating. And if we think about the sort of the supply of grains that use the Mississippi River extensively, this itself can start to become a bit of a concern moving forward. It also will make things like the hydroelectric power less reliable and can increase stress on electrical grids as we struggle to match sort of extreme events, as we can remember, if we do, from the extreme cold event a few years back in Texas when the electrical system was put under extreme stress from that. As a part of that, I think a lot of what we think about with extreme weather events, this volatility is, it's useful to know that, as we think about how these things have evolved over time, broadly speaking, extreme weather events contribute a fairly small share of total deaths globally. And those numbers have actually been going down. So this is, again, one of these where there's both good news and bad news. And a lot of this is due to improved warning and response systems that have been enacted in response to previous events. And so our ability now to see, say, for example, that hurricanes are coming and are forming weeks or often weeks in advance of when they might hit landfall has dramatically increased our ability to prepare in advance of some of these events. On the other hand, if we think about the trend of what's going on with the cost of these extreme events, we see that while the deaths are going down, the cost of the events are going up. And in many cases, this is because we've chosen to build and expand in areas that are particularly exposed and prone to being hit by some of these extreme events. And so at the same time that we've done a much better job at reducing mortality, we're increasing our exposure to a lot of these risks, even as climate change itself is likely broadening areas of where these types of events may happen, their frequency and their intensity. Climate change and nutrition, that figure that I showed from the Sam Myers paper has a lot of different pathways through it, but there have been a couple of studies here that I'm highlighting that suggest that that climate change is likely or is potentially will be contributing to increasing risk of mortality. A lot of this coming through from leading to higher food prices and contributing to likely poorer diets into the future. There's also been work that's looked at the consequences of CO2 in the atmosphere and what that does to the composition of the foods that we eat, with studies suggesting that increased CO2 in the atmosphere could decrease the nutrients that a lot of the crops that we eat may have through greater availability of carbon, leading to having sort of a dilution, particularly for protein, iron, and zinc in a lot of the crops that we have. This is a particular concern given that in many parts of the world that there are still serious micronutrient deficiencies, and this, while not maybe the first order impact of climate change, is just one other consequence that may be there that people will have to take into consideration. Higher temperatures also increase the risk of food-based pathogens. Thinking in terms of how we handle food, there's studies that have suggested warmer temperatures increase the risk to getting salmonella and E. coli and others kind of at the consumer end of the food system. But there's also plenty of evidence that's showing that climate change could also impact earlier in the food system in terms of contamination. There's increasing risk with aflatoxin, which is already a major problem for human well-being and health in places like Africa and Mexico, where aflatoxin is a serious issue in terms of quality of maize and peanut that are consumed. And so, climate change is likely to have many different impacts across many different systems through with consequences on human well-being. And so because of that, it's one of these wicked problems that are very challenging. There's lots of complexity and uncertainty. Adaptation to these types of things will need to consider how do we reduce our exposure and our vulnerability to the different climate hazards that are likely going to be coming into the future. What can we do to sort of reduce that? Certainly there's many different ways that we can do that. Urban design, improved infrastructure can play a serious role. There's already evidence that shows that improving urban design through more green cities can dramatically reduce the heat island effect. And so if we're thinking about those types of actions could have both a positive effect today, as well as reducing our vulnerabilities and exposure to extreme heat events in cities in the future. There's also evidence that these types can help with improving air quality in terms of reducing local air pollution. Even though if we also think about the trade-offs of these, it might then increase potential production of allergens in cities, as well as many of these types of plants will flower and produce their own issues. And so everything we do has potential positive effects and some potential negative trade-offs that we have to consider how we manage those moving forward. Continuing to think about things that we can do that can have both sort of positive effects on health, as well as sort of helping manage some of the climate risk. There's substantial possibilities of improvement across the food system. Broader adoption of healthy diets can help reduce emissions and land use, in that more healthier diets tend to be associated with much lower consumption of animal source foods than what we currently see in many high-income countries. And many of these foods require substantial amounts of resources to produce. And so reducing those can both lead to improved health outcomes while also reducing the environmental footprint of the overall food system. We can also look at, there's a whole range of different technologies and applications that we can also do that can improve the way that we produce food and reduce some of the risks that we face from that, whether that's through improved storage technologies that can help manage things like the aflatoxin risk that I mentioned earlier, or whether it's through increasing automation of agriculture, which can help reduce exposure to toxic chemicals. But again, all of these things have potential trade-offs, and automation can then mean less opportunities for labor and work, which can have issues in terms of livelihoods in rural communities. Mitigation efforts would be great. Anything we can do to reduce the amount of emissions that we pump into the atmosphere will only reduce the amount of risk that we're facing into the future. But it's also probably important for us to recognize that at this point, there's going to be some climate change that's baked in. We're already feeling the consequences now. And even if we were to stop all emissions tomorrow, we would still be having to find ways to adapt to the consequences of emissions that have already been contributed to the atmosphere. Nevertheless, that's not to say that we should just keep burning away. Every additional degree that we increase into the future will only sort of make the risk greater. And so efforts that we can do now to reduce our resource use and the emissions that we pump into the atmosphere, all of that will just have sort of more positive effects into the future with regards to reducing risks and negative outcomes that we'll have to manage. And I guess to finish up, thinking about a little bit of like, how do we think about these types of things? And it's just important to realize that all of the responses that we might have here will have trade-offs. We're dealing with complex systems with many interconnected pieces. Often we don't have full information. And so we just have to be cognizant of the fact that interventions that we do now to try to resolve problems will have unintended consequences. We need to think about, who is likely to benefit, who is likely to suffer the negative consequences of any changes, what are evolving power dynamics, and how do we sort of manage these things such that when we confront future challenges, that they don't derail us from moving towards a positive future that we're looking for. Ultimately, these are political discussions in terms of thinking about who wins and who loses from change, and thinking about how you create sort of a consensus vision of the future that allows for more collective action. Not easy work to do, but it's basically what's required of any sort of pathway of change, that there has to be these efforts to get into collective action and work more broadly as a group. And here's just some of the things that, if we're trying to think about doing this in a more fair and intentional way, is a framework that we've been thinking about in terms of how do we want responsible innovation and technology to develop, and thinking about how ultimately these things need to be social processes, social political processes that engage broader communities, with trying to ensure that we have the trust and the social license for the kinds of changes that we want, while recognizing that no actions are perfect, and so that we need to have sort of an adaptive governance system that allows us to act, but then to adapt as circumstances on the ground change and new problems sort of become more salient. So in conclusion, climate change, I think, is clear, poses a threat to human well-being along many dimensions. The impacts of these will depend a lot on how societies adapt, and the capacity of adapting for different societies are constrained by a great many factors, whether it's poverty, access to technology, exposure to the very hazards that are changing because of climate change, political capacity, state capacity to act. All of these things can constrain how different countries, societies, communities can adapt to these types of risks. And how we manage that will ultimately determine what the sort of final consequences of climate change will be into the future. But again, there are a lot of activities that we're doing today and could be doing today that could have serious benefits, and they could improve situations that are experienced now, and could strengthen capacities and resilience towards future climate change, and hopefully these are the types of activities that many of you guys might get to be a part of as you finish your studies and move forward into your professional careers, and can help sort of building sort of more positive futures that are more like that top green city vision instead of the much more dystopian view from this Netflix sci-fi cartoon. In any case, that's kind of I guess, a quick brush through a whole range of different potential consequences to human health from climate change. And I guess we could open it up to discussion or questions.
Thank you so much for that. That was fantastic and a great overview, but also some interesting aspects that don't get talked about a lot. One thing I was thinking of is just the terminology we use around the topic and how important that is into how people respond to it. So let's see. Does anyone have any questions? Let me look at the chat here. There's a comment here that says, you didn't say much about human behavior responses through risk perception to enhance the adaptation potential. Several recent studies indicate that the climate models which ignore these feedbacks may be too pessimistic. I don't know if you have any follow-up thoughts to that, Patton.
So I think that's there's a range of different types of models that have been used to try to project or estimate what the consequences of climate change could be. And certainly the ones that are primarily biophysical, I think generally speaking, overstate the likely consequences, because essentially what they're trying to do is do a counterfactual of, if nothing changes except the climate, what's like the consequence of that? But of course, that's, if we're thinking about realistic, that's crazy, right? Because at this very moment, farmers are changing their planting calendars every year based on how things are changing. So there's a whole range of different adaptation strategies that can happen. And so in many cases, when we start thinking about some of those that are primarily biophysical, it's somewhat helpful to think of them as sort of like, that's the worst case scenario of what might happen from a climate shock, assuming that nothing else changes. Now, of course, with the risk perception on some of those things, that could lead us to, in some cases, act from an alarmist perspective, and we could overreact to something, and then what we do might actually be worse than the consequences of what we're trying to resolve. And so there is a bit of a that risk perception can go in both directions in terms of how people interpret that, and whether or not the actions they do are well sort of targeted to the problem that they're dealing with. In this, I'm not sure like how these types of things will net out. I suspect that what we see is a lot of sort of small steps, evolutionary improvements that we do from the day to day will reduce some of the consequences. Improvements on technology and new approaches will certainly help reduce a lot of these the negative consequences we see from this. You already see this with improved crop varieties, but also you see this with improved urban design. Cities are now doing things to try to change the way that cities are designed, whether it's through stormwater drainage to handle higher flows of water because of increasing extreme rainfall events, or if it's through trying to bring in more sort of green urban environment. So there are quite a few different things that are happening. So I'm not sure that fully answers or responds to that question, but.
Well, can I just pipe in? This is Lou Gross. Thanks a lot, Daniel, for a wonderful summary. There now are really a lot of ongoing collaborations with social psychologists to really account for what we know about behavioral responses to a variety of actions that are related to climate change. And at least those models initially indicate that there can be significant rational basis for hope, as we call it, regarding this. And what I don't know is whether or not, aside from the sort of IAM kinds of approaches, the integrated assessment modeling approaches, whether or not the food systems folks have taken into account any aspect of human behavioral responses from the social psychology perspective.
I'm not sure with the like what is included in sort of the social psychology perspectives that you're mentioning, but there is a lot of work in terms of looking at like what types of things that farmers do in terms of adapting to changing weather and climate and practices. So there's a lot, I guess you could think of as more like agrotechnology and adoption and adaptation. There's also quite a bit around sort of energy transition and technology that's included in some of that. But one of the challenges, I think, with the integrated assessment and climate, and some of what I suspect is true of the social psychology literature that you may be referencing, is the scales sometimes are really hard to bridge. And so a lot of impacts, if we're thinking at the individual level, are they're really hard to bridge across sort of some of the modeling that's done at kind of high level global scales. And so when I've been doing some work, we've tried to do this by kind of connecting to household surveys and things like that, so that we can downscale what are the consequences of these global changes to local settings. But it can be kind of tricky because ultimately so much depends on the local circumstances. We've tried doing some stuff with participatory workshops where we present climate models as like an input to a discussion of what this means and what types of actions they think in a community, in a region, they should be doing. But not being super familiar with this, the social psychology literature, I'm not sure if that kind of maps over to what you're referencing.
Okay, thanks a lot. Yeah, we published a paper in Nature a couple of years ago about this. I'll throw it in the chat so people are aware of what we've done. Thanks.
Thanks so much. Joe, do you want to go next? I see you have your hand raised. Feel free to just unmute.
Yes, thank you. Thank you. I've got two items that I'd love to have Daniel respond to. First, Daniel, I thought the heat island effect is much higher than, if I heard you correctly, you might have said 4 degrees or something like that. I understand it's much higher, number one. Number two, the automobiles and trucks, as they're traveling along highways, are contributing to climate change. But there's also 3 pollutants that they're emitting: PM 2.5, brake wear powder, and tire wear powder. Those last 2 are very toxic, and all of them can be in forms of microscopic particles that, when you breathe them in, they pass through the walls of your lungs and go to your organs in your body, your brain, etc. And if you're a pregnant woman, they may impact the child or children that you're carrying as well. Can you speak to those 2 issues, the heat island effect, which I think is higher than you may have described, and are you concerned about the highway pollutants that are also particularly impacting at-risk communities that are downwind, particularly of north-south highways like I-5, I-35, and I-95?
So with the heat island effect, so the number I said, you probably don't want to use it as like quoting it strictly. I was looking at a range of different studies, and it varies dramatically from one city to another. And so that's kind of more of a ballpark kind of idea. There are places where the temperature is way higher effect of the urban heat dome. And in large part, this is just with how much concrete and glass that you're dealing with. And also it depends a bit on sort of local weather patterns in terms of wind and other things like that that can also influence that. So some cities, the urban heat effect is actually quite low and doesn't really have much of an effect. In others, I think you're absolutely right that it can be quite a bit higher than that. And so again, kind of goes back to, so much depends on just how we decide to do things, makes a major consequence on that. With respect to the the threats of the, I guess the different types of pollution that you're suggesting, I'm not super familiar with the interactions that these might have with respect to climate. Certainly, if the dispersal pattern is being driven by wind, then you could sort of think about whether or not the fact that you might start having more issues of drying and wet alternating with extreme dry and wet and wind. There are some studies that I've seen in terms of what happens with sort of drought and then rainfall patterns. What you can sometimes get is that some of these sort of pollutants can become basically inert in the ground, but then once you get these patterns of sort of extreme rainfall and then drought, they can basically then become part of, through sort of wind erosion, can be reintroduced and re-expose people to elements that before might have just been inert in the ground and not of any particular concern to anyone who wasn't like in the ground itself. And so if some of these things are becoming part of like kind of in the ground or in the topsoil, then you might expect that climate change might make the exposure to some of these worse. There's certainly interactions that we can see with what we're doing with contributing to climate change in ozone in terms of terrestrial ozone layer levels tend to be higher with the types of activities that we do that produce greenhouse gas emissions. And those obviously have quite negative effects on human and plant and animal well-being in terms of respiratory consequences, but can also then have consequences on agricultural productivity. But you know, in terms of tire wear, I mean, I would expect higher temperatures would probably make that worse, but I don't know if that would make the pollution worse. We certainly see that infrastructure, roads deteriorate much faster with higher temperatures and higher humidity. And if we think about tires in terms of whether or not some of that might become a greater risk because the infrastructure itself degrades faster, then that might be another sort of point where you could sort of see these the many or the myriad consequences of climate change on sort of the different factors that lead to human health. But I have to say, Joe, I'm not sufficiently familiar with those particular questions to give anything more than just kind of that general response.
Well, I wanted to make sure you and others were aware that, first of all, highways are a climate change vector, if you will. I mean, they're contributing to climate change. Certainly the tailpipe emissions are doing that. But both the tire wear and the brake wear powders, as well as PM 2.5, which is a tailpipe emission, are also contributing to adverse health impacts in many cases into the same communities that are suffering from some of the heat island effect and other effects related to climate change. And I hope a broader consideration of those multiple challenges will be thoughtful in everybody's mind.
Thanks so much for adding that to the conversation here. We've got one question in the chat. How are you and other research groups revising projections, if you are, given the new U.S. administration's departure from domestic and multilateral mitigation and adaptation efforts? So basically, what does the next 4 years look like, given some change in political policies?
Yeah, that's
feel free to answer that however you feel comfortable answering.
That's a really tough question to answer because I think we're in a state of so much uncertainty of exactly what the current administration's policies actually are versus what they say they are. And so I think in like if we're thinking about like the multilateral, if that's a reference to us moving out again of the Paris Agreement, I think as a signaling device in terms of our commitment from a national high level perspective, I see that as not a great sign in terms of just not recognizing that this is a serious problem that requires sort of a high level perspective and And so that I think is a negative, and it's hard to sort of know exactly how much of a consequence that will have on overall outcomes in terms of sort of a lacking of sort of that high level leadership towards trying to just recognizing that it is something that we need to do something about. However, having said that, it's not really clear that the US, even in previous administrations, was making like really the types of efforts that would be needed to achieve a 1.5 world. And so it's not so obvious that us moving out will have like a dramatic effect on that. We do see that there's a lot of economic consequences of just changes in how sort of the cost of different energy production is driving transitions towards more use of renewable energy, particularly with the expansion of solar and how that's reduced in cost. And increasing interest in things like electric vehicles and more electrification. So there are some of these things that are happening and ongoing that I don't think these are trends that are already moving in one direction. So I don't see them necessarily being driven by sort of federal policy. And so I suspect we'll probably continue moving in that direction. Obviously, I'm the sort of gutting of research and science focusing on issues of climate change, weather and the environment. That to me is a potentially a high risk in terms of reducing our capacity to know what types of challenges we may be facing and how to start planning to adapt to them into the future. And I think that will have serious negative ramifications. Hard to know like how much. A lot of this is almost like we're going to be talking about like proving, how do you prove like a negative or a counterfactual of something not being there? So it's a little bit tricky to know. I'm very worried about what we're doing with an attack on science, broadly speaking, because that's one of those things where if we don't ever develop certain areas of knowledge, we don't know that we could have developed them. And so it's this a potential risk there of impoverishing our capacity to act to threats into the future by not having more of that. So it's hard to sort of put a number or anything on it. I'm worried by the trends that we're doing in terms of the actions. I think we're suggesting that climate change is not a serious threat, and sort of questioning or seeming to want to question whether it's a reality. I think it would be a much more positive space if we could all agree that climate change is in fact happening and is serious, and then focus the discussion on, well, what do we do about it? Because how we respond to that can go in many, many different ways. And it would be a lot more positive if we were focusing our discussions on how to respond to it, what are the benefits and costs of different options, then sort of having this kind of continued sort of, I don't know, undermining of whether or not climate change is happening. But I
think
guess
that's
on
an
the
incredibly
more
insightful
optimistic
place
side,
to.
I don't think there will be 4 years of inaction. I think what is going to be seen and what has often happened is that a lot of this work is grassroots and then it starts to percolate up. And there's definitely a lot of value of having that high level sort of perspective that can help provide perhaps a bit more coherence and cohesion to action. But I don't think we're going to see 4 years of inaction, because I think there's lots of people who are taking this seriously and will continue trying to act in that respect. And so I think we'll continue to see progress on some of these, but maybe just not as much as we could have if we were doing this as a all hands on deck kind of situation.
I think that's a super helpful perspective to end on, and maybe a call for us to be optimistic about what we can do kind of at this, like you said, grassroots on the ground level, and then working on communicating that science that we're doing upward. So let's see. I don't see any other questions in the chat. Does anybody else have anything? We've got just a couple more minutes. All right, it doesn't seem like it. And I think that's a positive place, positive note for us to end on. So thank you everybody for being here.